Welcome. Has everybody entered? Yeah, good. Welcome to my presentation on the Tale of Two Pizzas, an overview of developer tools at AWS. That's me. My name is Darko, or Darko. I come from Serbia. I'm actually based from, well, I was born in Subotica, which is a town just 100 kilometers north of here. Currently, I am a solutions architect based in Berlin, Germany, and I work for Amazon Web Services. I've been working for Amazon Web Services for 3.5 years now. As a solutions architect, I help customers who use AWS services to use them in the best possible way. That means I help them architecture their workloads, their infrastructures, according to some best practices we can. And that's my Twitter handle, right? As any presenter has to have. So, why are we here today? What are we going to cover today? First off, this talk is going to be split into 3 sections. We're going to discuss the lifelong question, what is DevOps? We're going to look at at the Amazon DevOps story. And we're going to have a look at some developer tools behind AWS that can help you achieve a lot of these things. And hopefully, if we manage in the 45 minutes, I'm going to actually demo something because I don't like presentations where there's no demo. So, software moves faster today. I used to work for a company in Serbia that we had a super slow release cycle. It wasn't even a quarterly release cycle. Basically, we would have a development team that would spend 6 months on a feature, build it numerous times, use a build server, all those things, and then once every year or twice a year, they would actually deploy it. It's much different now. You can see companies deploying features and updates many times a day, not so long the quarterly release cycles, right? And this is where we run into problems, right? We release software much more often, but that doesn't mean there's a lot more people doing the same job. So, who can tell me? Well, who thinks he knows or he or she knows what is DevOps? What is DevOps? Okay, that's one way to say it, right? It's a cycle where we have customer requirements, bringing it to developers, pushing it to operations, and getting feedback from it, right? Everybody has their own definition of DevOps, right? DevOps is not a DevOps.py. DevOps is not a DevOps.exe. DevOps is not a person you hire. DevOps is a set of culture philosophies, practices, and tools that actually help you achieve a lot of these things somebody mentioned in the crowd, right? So, the DevOps culture. This is usually the most complicated thing. One thing is to set up your CI/CD pipeline. Yeah, that's relatively easy. One thing is to set up monitoring. Yeah, you can do that. But getting the right culture inside of your organization to adopt DevOps is very complicated. That means developers and operations come together. Who here has heard the thing that, oh, we can't use DevOps because it means I need to have my sysadmin do code, right? I heard that many times. Like, oh no, we can't adopt DevOps because our system admin, he doesn't know how to code. That's not the point. The operations folks and the developer folks work on the same product in the same silo, if you want to call it, right? That's why we eliminate silos, independent silos. In this company I used to work for, the application folks, as we used to call them, sat on the other side of the room, and we would talk to them once a year, which was horrible, right? Shared responsibility. There's no more us versus them. We, both ops and dev, own the product, right? Ownership. We own our business value. We own the thing that makes us money. And we work on it together. We have full visibility in what each others are doing, right? And full communications. Going back to my previous example, the application guys actually one day decided, you know what, they need a faster server. So nobody came up to me and say, hey Darko, can you just order us a new server or get us something more? No, they just went out and bought one. Monday morning I come to the office, there's a big box on my table, like, hey, you have to set this up. I have no idea what that is, right? This causes problem, causes delays, causes a whole lot of things, and causes me not to like them because they went over my head and decided for themselves. That's not collaboration. Microservices, right? Everybody's talking about containers, right? Serverless now, it's 2019. Moving away from a monolithic application, we had a monolithic application, a single binary, a single thing that, that delivers a value, right? And any change to that causes a problem, right? I'll get to this in a bit, right? This is how you would transfer a monolithic application to a microservices one, right? Microservices are not necessarily containers, mind you. People think, oh, microservices, oh yeah, we have set up Docker and Kubernetes. Microservices are microservices, independent services that have contracts with each other through a series of APIs that work together to deliver a common business goal. CI/CD. Everybody heard of CI/CD? Who can tell me the difference between delivery and deployment? Does anybody know the difference between delivery and deployment? Nobody. Well, one person. There you go. I'll repeat this for you, but one of those, delivery requires a person to say, ship it. That means it requires interaction to get the product to the final stage. While continuous deployment, there's nothing involved. That's the holy grail. As soon as your developer submits a piece of code to the repo, that piece of code should end up in your production application, right? CI is the most common one. Commit your code, build it, end of story, get somebody else to deploy it. CI/CD is also not DevOps, right? People think, oh, I have CI/CD, I'm DevOps. Wrong. Infrastructure as code, right? Who uses any sort of infrastructure as code? CloudFormation, Terraform, CDK, Troposphere, right? Yeah? So this is also part of that, right? Helps us define our infrastructure. There's no longer racking and stacking. Instead of racking and stacking, let's write a template. Let's templatize our infrastructure. With AWS CloudFormation, you can either use JSON if you're a robot, or YAML if you're a person. So this is an example of JSON, but yeah, something like that, I guess. And also, monitoring is important because one thing is to move fast, one thing is to have things repeatable, so infrastructure as code. One thing is to set up dev test environments. One thing is to communicate with your peers. But if you do not monitor and log and improve on what you have done, you're actually not embracing the full DevOps experience. So with proper monitoring, with analyzing metrics, and understanding how your application performs, what are your business or application KPIs, right? That way you kind of get the full picture. So wrapping all of this up, the benefits of DevOps. You probably heard this 100 times, but improving collaborations, giving you the ability to talk to your people, and with that, increase the speed and delivery of your application. With all the tools here, you can increase the reliability, security, and be able to do that at scale, all while moving fast. This is the fun part of the talk. This is no longer dry DevOps thing. Let's have a look at Amazon. How did the development story look at Amazon? I'm not talking AWS, I'm talking the shopping platform, right? I know it's still missing in Serbia. I get to enjoy the full benefits of it by 2-hour delivery and all that stuff, but yeah. So, Amazon.com, 2001. One monolithic applications. A lot of teams writing the same piece of application. I do believe it was written in C++, And by some information, if I can recall correctly, it took 24 hours to compile, right? So if Bob puts a change that makes the shopping basket use a different font, or look a bit different, or act a bit different, it takes 24 hours for that change to be pushed into production. And that's a big application, mind you. It's not only Bob adding features. There's 100 or 1,000 more people making changes, right? So in 2009, Amazon decided, you know what, let's do microservices, right? There was no concept of today's concept of microservices. We used to call it primitives back then. So we split this monolith into a whole bunch of primitives and introduced the concept of two pizza teams. Has anybody heard of a concept of two pizza teams? Okay, cool. Basically, it's very vague, same as DevOps, right? So two pizza team is a concept of you should not have a team owning a product or a part of a product that you cannot feed with more than two pizzas. So I'm a pizza team, I guess, right? So I can be a pizza team by myself. Depends on the pizzas, I guess, right? So we don't know how much people can eat. We don't know the size of pizzas. And yeah, so it's pretty vague. So yeah, we moved from a monolithic applications, from a single binary, to primitives. If you look at 2009, and you have this service map, right? So today you have these big service maps of your microservices applications with different services running and containers and whatever. It can be complex. This was Amazon.com in 2009. It's so big, yeah. So there's many hundreds and thousands of microservices, or primitives as we used to call them, in 2009. I can just imagine that 10 years from then, there's a lot more now. This was good, right? So moving a bit fast, people were releasing services. I think there was a number, not sure if I have the number here, but we released many features per day, just because of these microservices, right? But we were not satisfied yet. So in 2009, we sent out a study to all the developers and all the ownership teams within Amazon. How can they improve this? What can we do for them to make their lives better, right? So to find out where are the inefficiencies. What we learned was that the problem was everything was taking too much time. So even in a microservices model, things took time, right? I am a developer, write some code. He has to wait because he sends the code to the builder's guy, right? The person building the code has to wait, right? Builds the code. The person building the code sends the code to the deploy guy. The deployment guy has to wait a bit for some reason, right? And then deploy the production. So even though it took a couple of minutes for you to change your code, ideally, right? So it does take a longer time. But it takes days between that and actually getting the code to build. It might take days to build the code, especially in a big monolithic model. It takes maybe a couple of minutes to deploy it, right? But there still has to be a lot of delay time before it getting into production. We have fancy colors here. So a single deployment, even though it's microservices, could take weeks from the actual deployment phase, or coding phase, right, to be in prod. And in 2001, that could have worked, right? So in 2001, I was in elementary school. So back then, I don't think we were too stressed about having the latest version of Instagram outside, and so everything moved much slower. But it's 2009, right? And it's 2019 now, so we need to move faster. So what can we do? How about we take out these things? The point from me writing the piece of code and getting that code to somebody to build it, and getting the build code to the deploy guy, and the deploy guy getting the code to the production. Let's eliminate that and move the time from weeks to just hours. So we built tools. In Amazon, we decided, like, okay, let's build tools. Let's build pipelines to automate all of this. Let's avoid having to get the tool to somebody, or get the code to somebody, or wait for somebody to deploy. So with pipelines and automated actions, from the code check-in, from the git push origin master, or whatever you do. It was much faster to get it to production. So first of all, it's fast, right? It's safe because you test every step of the way. I don't give my build guy a floppy disk with my version of the code, and then he compiles the wrong version, and I get the wrong version in production, right? It's all streamlined, it's all standardized. Everybody in the company is building the code in the same way. Also, it's very transparent. Everybody in the company, from the product owner to the CFO, can see where in the process of actually deploying this change are we in, which can be good and bad. So in 2014, we had thousands of services across Amazon. We were building microservices. We were doing all the CI/CD stuff and a whole lot of environments, and we were doing 50 million deploys per year. Who can say that, right? How many deploys that per day? I don't want to count. So a lot of deploys per day. So all this combined, and giving the tools, pipelines, all of the services we have to our developers, made them happy. And there's nothing better than happier developers, right? So where do we start? So this is me talking about Amazon, something abstract to you. Somebody might never even used Amazon or doesn't even care about Amazon. That's perfectly fine. But how can I help you guys sitting here achieve the same sort of happiness, right? Well, allow me to talk about Amazon developer tools, right? Is everybody here a developer? Are most of you developers? Who's a developer? Show of hands. Most people. Okay, cool. So you understand the release processes of a feature or a piece of code, right? So you have the source where you would check your code in, right? Java, Python, maybe even Ruby. You would build that code. You would actually use like tools like Maven or whatever, right? Build the code, actually test the code, do some linting, style checkers, create the container images if you're using microservices, right? Then you would test the code. You would do integration testing. You would test if your change actually works with everything else. That's really important, right? You want to do load testing. In the modern world, you also want to do limit testing. You want to be sure that if you're running this on the cloud, you can actually launch it in the cloud, because people can launch things and not have enough limits, and then it's a problem. UI tests. So we want actually to people have a look at what we changed and say, yeah, this works. This works on my phone. This works on 100 different tablets, whatever. And penetration testing. That's quite important. And finally, deployment to the production environment. So this is what we start, and this is how we want to end. I think most people do it this way. Is there somebody here that does it differently? Good. I had the good crowd. So talking about CI/CD back again, because CI/CD is, as I said, it's not DevOps, but it's kind of important here. So if we look at all these four phases, CI is this, continuous integration. From committing your code to building it, testing it maybe, right? And then you would have a built artifact, which in some way or form, you have to deploy to a production environment. Then continuous delivery, which is all the same thing. So you commit your code, you build it, and then after all the testing is done, all the UI testing, all the penetration testing, somebody looks over the results and says, yeah, ship it, this can go to prod. And as I said, the holy grail of all these things, continuous deployment, which is from the moment you commit your code to the moment it makes you money, it's all automated. Now, talking about all this, and talking about all the tools I mentioned before that we build internally to help our production teams deliver better services, whether that be in Amazon.com or AWS or any of our other services we offer, we have decided to do the same thing and offer it to you guys. So take the experience we have, building those tools, and actually offer those tools to the people out there. So we have AWS Code Services. AWS Codestar, I'm going to go in detail about all of these, but these are kind of the icons we do not officially use, but yeah, these are not the console icons. But we provide a set of tools for CI/CD. And how do these fit in, right? You may be able to determine by the names, because they're pretty, unlike some other services we have, I think we did good naming on these ones. CodeCommit, right? This is where you commit your code. It's basically a Git repo. Code build, it's used for building code, right? We don't have testing tools. We do not have our own, let's say, any of those, we do not have penetration testing tools. We do not have UI testing tools. But this is where a third party comes in, where our vast array of partners we use and which run on our platforms can actually help you run these tests, right? And finally, the deploy phase of this is AWS Code Deploy, which, as the name says, actually delivers that code to some production system. And all of this tied in with AWS Code Pipeline. Code Pipeline, as I said, is the service that kind of emulates this pipeline that takes code from one stage to the other, to the other, to the other. And Codestar, which is the demo I'm going to be doing because it's actually the simplest demo to do, and it's the most visual thing, is the service that unites all of these things and can actually provision this entire pipeline along with all the required infrastructure you need to provision some sort of a application in a DevOps CI/CD fashion. Besides this, I would really like to mention some other tools which we have in our DevOps portfolio. From the code tools which I mentioned here for CI/CD to infrastructure as code, we do have CloudFormation, AWS OpsWorks, AWS OpsWorks for Chef Automate. We have for Puppet Enterprise as well. So these tools provision and configure your infrastructure. And we have monitoring and logging such as X-Ray, CloudWatch, CloudTrail, and Config, which actually performs compliance checks on this. I think this is an older deck, so we are missing, AWS Systems Manager. Systems Manager sits in between, it's kind of like on the infrastructure as code part, but it's actually an operations tool which performs operational tasks, such as if your instance is bleeding out memory, it has a memory leak, you can use Systems Manager to automatically restart a service on it, for example, remotely. Build and test your application. Let's talk a bit more in detail about the services I mentioned before. I'm good with time? Yes, I am. So, code build, as the name says. So who tests their application? Who does test-driven development? Both of you. That's good. Okay, should I be scared? So, code build. Besides just building your code build can also actually test your code. So, simply put, what code build does is launches a container in the backend somewhere and runs arbitrary code that you provided. It takes the artifact from the CodeCommit repository or any repository provided. It can be GitHub as well, it doesn't matter. Takes the code, builds it, and it can also interact with that built artifact to test it or lint it or whatever, right? It's completely running in a black box, right? So it's a fully managed service. You pay by the minute. And besides some build environments that we offer, such as for Android or Java, there's also custom build environments by you providing your own Docker images. It can be launched with Code Pipeline and Jenkins, and to be fair, it can be launched with anything because there's an API call for that, right? Let's talk about testing. Testing is important, right? So there's no best practice for testing. When people ask me, so how should I test my code? Well, it depends, right? So that's why we say it's a science and an art form. It depends on what your code does, how you test it, and basically what's the value out of it. And can you test it as well, right? Basically, the goal of it is you want to determine its desired functionality. Ideally, so if in an ideal world, you wouldn't test a single piece of code. You would test the business outcome of that code. So if a business outcome for me is to sell more shoes, yellow shoes, I would want to test my code. Does it increase or decrease the amount of shoes I sell? It's very difficult to do that, right? But there's some customers of ours that do that as well, right? With this, you can, of course, besides just catching programming syntax errors, that's just a given, right? You can standardize the code patterns and hopefully reduce bugs, right? And make applications more secure. This means by introducing custom build or testing models, you can ensure that some certain practices are followed. What to focus on your tests? This was made by somebody in Amazon, and this is how we kind of do it. 70% of your tests should be unit tests, 20 should be service, and only just 10 UI, because UI, I guess, right? So it's 10, 20, 70 mix. How does this fit into the tooling, right? Unit test can be done with code build, but everything else is kind of the part of the third-party tools I said. So we have our application. Bob has committed his application to a Git repository. He built it using code build. Now it's tried to deploy it, right? In the old days, you would throw a floppy disk across the room to the guys deploying your code and say, make that run. Hopefully we do it differently right now. So, as the name says, AWS Code Deploy automates code deployment to any EC2 instance. Actually, not just EC2, it can do on-premise instances, it can do instances in different cloud vendors, whatever, right? It doesn't differentiate. It handles the complexity of updating your applications. So, when you update your application, it's not always a thing of, hey, let me just copy the new binary over, or hey, let me just copy this single PHP file, or whatever. There's actually a whole lot of things you might be able to do. Stop your application, reset the cache, or relink some database, whatever, right? So and Code Deploy can actually do that thanks to its hooks. Basically, during the deployment, it can do some things as well. It actually integrates with third-party tooling. I can imagine a lot of people here use Jenkins, and Code Deploy works very nicely with Jenkins. So you can use your built artifacts with Jenkins and deploy them with Code Deploy. One thing I left for last here is that rollback is important. So rolling back a complicated change, rolling back a single binary or a single PHP file is not a problem, right? But rolling back a complicated change is where the fun begins. Thanks to Code Build, and it actually knows the state of your application prior to deploying the new version, rollback is just a piece of cake. It will automatically roll back if a health check has failed after the deploy, right? So you don't even have to worry whether this will break your production or not, because it will automatically go back and you will see it immediately. All this is fine and dandy, right? From the commit repository and building the code and deploying the code, we need to tie it all together. And this is where Code Pipeline comes in. So Code Pipeline is this CI/CD service we offer that allows you to reliably and fast update your applications. What I mean by that is that you can take your application from the source code phase to the production quite easy and quite in a standardized manner. One thing I don't have a screenshot of our internal tool, but our internal tool literally looks like a pipeline. So looks like this Super Mario green pipeline, right? And from one end, from the left side, you have your commit, and then you go right through production. Now, that was fine. It's kind of logical, right? But our developers don't like that because it doesn't fit on the screen. So in the productions tool, like actually the thing we deliver in AWS, such as Code Pipeline, we flip that over. So it's a vertical pipeline from the top to the bottom. So that's the nice thing. And last but not least, definitely, is CodeCommit. This is the thing where it all starts. As I said, it's simply a Git repository where you can use any of the standard Git tools, right? It's backed by Amazon S3, so it has this very reliable 11 nines reliability of storage. And it's encrypted. There is no limit on the repo size. You can use CloudWatch events. That means, for example, if somebody commits a code, you can trigger an email that a code has been committed. You can do any sort of task you can automate with APIs or code you want, right? So if somebody commits a code, you can just ping everybody in the company, I guess. Yeah. It uses git pull push over SSH or HTTPS, stored on S3. It's indexed on DynamoDB, so it's serverless, right? And it uses AWS key management service for actually encrypting it. And finally, introducing AWS Codestar. This is a service that takes all the elements I talked about before, and then some, and helps you securely and rapidly deploy a single application with all the tools you need to code for it, to code, test, deploy, and even collaborate with different people on the same thing, right? So you can choose, we have a built-in template system, so you can choose from a variety of products, and let's hope that grows, right? Now, this is difficult to visualize, right? So let me try to demo this, right? So, Codestar. Let's see, hopefully the internet works. Do I need to do this? Yes. Can I do this? Yes, good. All right. So, this is AWS Codestar. Let's create a new project, right? Call it, let's choose Python, because I like Python. Let's do it serverless, because it's 2019. And give it a name. Demos never work. I will choose CodeCommit as my repository, right? I can use GitHub as well. But I come from Amazon, so I guess, right? And this is what it will do, right? It will create a CodeCommit repository. It will create a code build service. It will use CloudFormation to actually deploy the code to a Lambda function. And it's going to use CloudWatch for monitoring. And all of that with Code Pipeline. So click Create Project. Now, how can I edit my code, right? So I can be just an engineer and use a command line. I can use Eclipse or Visual Studio. To be fair, it doesn't really matter. You can use it wherever, as long as you have Git access. Or I can use Cloud9. So I haven't mentioned Cloud9, just because I want to demo it. So Cloud9 is our service that allows you for a in-browser IDE. So it's a very powerful, very integrated IDE that runs off a browser. So that means that instead of having development environment on every workstation I own, I have, I think, like 4 laptops, and I have a desktop at home, and I have my iPad and whatever. If I want to jump around and choose different devices and still work on the same piece of code with all the same settings, I can just use Cloud9, right? So let me choose Cloud9. And Cloud9 basically launches an EC2 instance, a virtual machine in your AWS account with all the required things, right? Now, this is setting up a project, but as any good cooking show, I have this thing already ready from the oven. So I have created a project called Coding Serbia, and this is how the landing page looks, right? I can introduce team members. I can collaborate with people here. I have a wiki site. It's automatically created, right? I have a Cloud9 environment. I can code my application. I have my pipeline from source to build to deploy. I have my commit history. I can blame people. I can see, Codestar deployed the code that broke my initial deployment. No. I have, where it is? I have monitoring. I can see my application activity, right? And I can connect it to Jira as well. So what is this application? That's my endpoint, right? Open this. It says, hello world. Of course it is, right? Now, it's a serverless Python application running on AWS Lambda using API gateway as the endpoint, and it just spits out hello world with the current date timestamp, right? Now, how can we make changes to it? I can go to the commit repository, I can check it out, make changes, commit it, and hopefully it works, right? Or I can open my Cloud9 environment, right? I click here. Wait a few seconds, because if you don't use Cloud9 for 30 minutes by default, it actually shuts it down, so it saves you money, so yay. And come on. This feature is being actively developed, so expect amazing new features from this one. I like it, even though I like my terminal, but you'll see why. Who thinks Vim is better than anything else? One? Wow, okay. I'm sad. Okay. What this does right now, it automatically clones my application. It clones my application to the Cloud9 environment, right? So, is this big enough, I guess? Maybe it could be bigger, yeah. So if I go here and have a look at my index.py, I can say that it does hello world. Let's change that, right? Please rate the session in the app. Oh, it has Vim keys, right? So if you are, if you like Vim, you can use all the Vim features of the editor itself. Or you can just be like me sometimes and just open Vim in this thing, but yeah. So I've changed this, right? And I need to git config global user name Darko. Yeah. Git config global. Okay. Git add all git commit messages are hard. Git push origin master. Yay. Now, if I give it a second, you should be able to see some activity on the right-hand side. So the source thing will start to spin. How am I with time? Oh yeah, I'm good. It actually detects, hopefully, it detects a change to the CodeCommit repository by the means of those events, as I mentioned, and actually triggers the change through the pipeline, right? So, yes, you can see my commit messages are hard. It was so fast, eventual consistency, right? It was so fast that I didn't even see it on the commit phase, but it's doing the build now. And shall the build gods be good? Demo, please. Work. So, this should really take a short amount of time, right? But I knew it's gonna fail. I'm having a stupid act here, right? So, it failed, right? Why did it fail? So let's have a look at code build. Why did this thing fail? Looking at here, we have build history. It says failed. Okay. Let's click on this thing, and the log output. Oh wow, there's logs. Collecting, downloading, whatever. Ooh, failed. Unit tests. Did somebody say testing? Right. I have tests on my code, and my unit test failed. Why didn't my unit test fail? Oh, look at the test directory. There is a test handler. Oh, the test handler expects a hello world in the output. Oh, wow. Okay. Let's change this, right? Let's add this thing and add it here. Like that. Git add all commit I I heard of a person getting fired because of commit messages, so be careful. What's gonna happen now? I made a change, I made a boo-boo, right? And I made a change now. So hopefully, now I can see my commit on the left-hand side, see coding Serbia. Hopefully now we should see the build trigger again. Mind you, my application is still running. Even though I made a mistake, the application itself is still giving us a hello world, right? So I have not broken anything. Well, per se. But the build is in progress. Let's see what happens. Now, hopefully, now if this actually fails, then this is out of script, but it should work now. Famous last words. And I have 4 minutes, which should be sufficient, hopefully, right? Did I mention speed? Basically, what I can also do is I can actually look at the code build while it's happening, but I know, okay, the build succeeded, right? The deployment phase is happening. Now, we're using CloudFormation to change the Lambda script, which is serving our serverless application. And hopefully, once the deploy has occurred, which should be relatively fast-ish, hopefully, we should be able to test our new application. Drum roll, please. Somebody told me the tools are slow, but you should try it out 10 years ago when you have to get somebody actually to deploy it physically to a box. Let's try our luck, right? Still not deployed. The great thing about Lambda functions is that it will actually, the old one will still exist while the other one is actually fully deployed, even though it exists as well. So once the full deploy cycle happens, until the full deploy cycle happens, both of them will exist at the same time, but only the good one will be able to be triggered. 3 minutes left. This talk was designed for 1 hour, but I had to cut a lot of content. So I was actually explaining a lot of the nitty-gritty details about each service, which includes configurations, but I don't think that's sufficient for 45 minutes. And not yet. Shall we have a look? What's happening with CloudFormation? Yeah, okay, actually it has deployed. It should have been deployed. Now we just need this to be confirmed as deployed, right? Maybe a refresh helps. Doesn't. Nope. Well, while this thing deploys, right? Let me see if I have some more slides. Yes, I need to recap what we did. I'll give it a minute. Come on. Maybe this? Nope. Well, wait until the end. So just a recap a bit on this, right? Does this work? Yes. Yes. No, wait. No, wait. Let's start over, right? Demo failed. So what have we done today? We talked about the 2 pizzas, right? 2 pizza team. Your team shouldn't be bigger than what you can feed with 2 pizzas. DevOps. We talked about what is DevOps, what is not DevOps, and what could be DevOps, right? We saw the code services, right? We saw all the features we built internally actually deployed to you guys as well. And we had the sweet Codestar demo, which, let's have a peek, is still not running, right? Yeah. Deployed. Wait. Haha, I'm happy now. How does one do this? Yes, that, Windows. Yes, there you go. We've managed to successfully deploy our application after a lot of asking it to do so. And this is just eventual consistency. So there you go. Once again, can I do this? Oh, Christ. Nobody likes PowerPoint. thank you very much. I will be here. I hope you enjoyed all this. I'll be here somewhere outside mingling. You should be able to recognize me if I can answer any questions you might have. But thank you for bearing with me through this amazing demo, and thank you for listening to me.